Hello everyone. Today I am presenting our CSE 427 project titled Student Alcohol Consumption. Alcohol consumption among university students is a serious concern because excessive drinking is strongly linked to poor academic performance, mental health issues, and long-term health risks. The main objective of our project is to analyze how alcohol consumption affects students' final academic grades using regression based machine learning techniques. For this purpose, we use structured student dataset containing demographic, academic, social, and lifestyle attributes. Alcohol consumption variables were included as key influencing factors, and the final grade of student were treated as target variables. Multiple regression models such as linear regression, SVR, neural networks, gradient boosting regression, random forest regression were implemented and evaluated to understand this relationship. Alcohol use is very common in universities life and is often associated with social activities, especially during weekends. While moderate drinking may be considered normal, excessive alcohol consumption can negatively impact concentration, attendance, and academic engagement, leading to lower grades. Many traditional studies depend on survey based methods, which may contain bias and limited scalability. In this project, we used machine learning as a data driven approach to analyze real student data and explore the impact of alcohol consumption on academic performance more accurately. In our literature part, from the papers we reviewed, previous studies shows that student alcohol consumption is influenced by factors such as peer pressure, social interaction, and smoking behavior. Research also suggests that higher alcohol consumption is associated with lower academic performance. Several studies recommend using regression based machine learning models to capture these complex relationships, as student behavior is not purely linear. Ensemble based models such as random forest and gradient boosting have been shown to perform particularly well when dealing with behavioral lifestyle data. Based on these findings, we selected multiple regression models and compared their performance in our study. The dataset we used in our project contains student demographic information such as age, gender, family background, study time, previous failures, including free time, going out with friends, smoking behavior, and internet access. Alcohol consumption is recorded separately for weekdays and weekends. The final grade of the student, known as G3, is used as the target variable. In our code, the dataset was separated into input feature and the target variable to prepare it for regression model. In our EDA part, during EDA analysis, we observed noticeable variation in final grade based on alcohol consumption levels. Most students reported low to moderate alcohol intakes, but a significant group showed higher consumption levels, which was associated with lower final grades. Weakened alcohol consumption appear to have a stronger negative impact on academic performance compared to weekdays drinking. We also found that students who frequently go out uh, and smoke tend to consume more alcohol and achieve lower grades. These relationships were visualized using graphs and correlation plots in our code. When processing our before training the machine learning models, we perform several data pre-processing steps to ensure the data quality. We checked for missing values and found none. Categorical values were converted into numerical form so that they could be used by machine learning algorithms. Now, numerical features were normalized to reduce scale differences. Finally, the dataset was splitted into training and testing sets using an 80 to 20 ratio, and the final grade was treated as continuous target variable. If we see our code, we can see in our data preprocessing part, we search if there was null values or any duplicate values. Then we performed one hot encoding, feature scaling. Then finally the preprocessed data and splitting the data into 80-20 ratio. Then the rest of the report my teammate will continue to explain.
Hello, my name is Tanzia Mihrin and I will continue from here. Firstly, I will talk about the methodology, what means like which models we have used in our project. Firstly, this project follows a regression based machine learning approach to predict student alcohol consumption using the demographic, academic and lifestyle related features. So firstly, we have used a linear regression model as the baseline model to understand how well alcohol consumption can be predicted using simple linear relationship between the input feature and the target. This model provides a reference point for comparing the effectiveness of more advanced models. Then secondly, we have used the HVR support vector regression model to capture nonlinear patterns that the linear regression could not model effectively. Student behavior data often involves complex relationships influenced by social and lifestyle factors, which are not always linear. SVR attempts to find a function that fits the data within an acceptable error margin while maintaining flexibility. This allows the analysis to evaluate whether introducing nonlinearity improves prediction accuracy compared to a purely linear model. Then next we have implemented random forest regression model as an model to improve prediction performance. This model builds multiple decision trees using different subsets of the data and average their predictions. By doing so, random forest captures interaction between features such as social activity, smoking behavior, and alcohol consumption while reducing overfittings. This makes it well suited for structured tabular data like the student dataset we have used in our project. Then we have also implemented the gradient boosting regression to enhance the prediction accuracy. Unlike random forest, which builds trees independently, gradient boosting trains models sequentially. Each new model focuses on correcting the error made by the previous one. This step-by-step learning process allows the model to capture complex pattern more effectively and often results in better performance on regression tasks involving behavioral data. And lastly, we have implemented a neural network model to explore to assess whether deep learning techniques could improve prediction performance. The neural network learns pattern through multiple layers and nonlinear transformations. However, because the transformation, then we have implemented lastly we have implemented all these models in our project. So if we see in our code, we can see that we have implemented all the 5 models here. So here we can firstly say that we have implemented the random forest model, then we have implemented linear regression model, then we have implemented the gradient boosting, then we have implemented HBR, and lastly we have implemented the neural network model. Then next we have as it is a regression problem, so for comparison we have used R-square and MEC score. So here we can see that the performance of each models here. So firstly, the linear regression model here, its accuracy is 72% and its error is 5.66. Then the HBR here, you can say its accuracy is 67% and the error is 6.79. And then we have implemented the random forest, which accuracy is 81% and the error is 3.83. Then we have implemented gradient boosting, which says accuracy is 80% and error is 4.02. And lastly, we have implemented the neural network, which accuracy is 64% and error is 7.42. Here also in code we can see that the model training part we have implemented. Here we can see the model evaluation part. We can see the R-square score and MSCE score for all the models we have implemented here. All of that models, MSC and R-square score is shown here. So we are also showed the comparison between all of the models by the R-square score, like how the accuracy is different from each other. In code, we also have showed the R-square comparison between the 5 models and also the MSE comparison between the 5 models. Then we go to the next part, is the result part. Here we can see that the experimental result demonstrate that based on the model's significancy over performance simple linear approaches, a linear regression exhibited limited prediction power, while SBR captures nonlinear trains more effectively, and random forest and gradient achieve the highest R-square values and lowest MSC. And here you can see that the neural network gives the lowest accuracy between all of the models here. So if we go to the analysis part, we can see that from the model comparison, we can clearly see that different models perform differently while predicting student alcohol consumption and its effect on the final grade. Firstly, a linear regression showed a limited performance. This means alcohol consumption cannot be explained using simple straight line relationship because student behavior depends on many interacting factors. And here the HVR performs slightly better than linear regression because it can capture non-linear patterns. However, this performance was still limited because it is sensitively to parameter selection and does not handle complex feature interaction very well. And the best performance came from random forest and the gradient boost models, because these models works better because they use a combined multiple decision tree, capture interaction between social, academic, lifestyle features, and reduce overfitting compared to single models. This is especially important in our datasets where whether features like smoking behavior and free time influence while alcohol consumption together, and this combines behavior negatively affect final grades. Lastly, the neural network model performed the weakest in our analysis. This happens mainly because our dataset is very small and the data is structured and tabular, as neural network usually need large dataset to perform well. Moreover, recent researchers demonstrate that gradient boosting and random forest model constantly outperforms deep network neural networks on structured tabular data due to their ability to capture features interaction without extension tuning. As a result, the neural network model in this study likely suffered from overfitting and weaker generalization compared to the other models' performance. So, in a discussion, we can say that the strong influence of our social activity and smoking behavior over observed in this study aligns closely with finding reported in prior researches. So, students who consume more alcohol, especially on weekdays, tend to achieve lower final grades. Alcohol has stronger negative effects while combining with smoking and frequent social activity. Lastly, we can say that alcohol consumption has a clear negative impact on students' final academic grades. Like a machine learning models outperforms simple models, and here also in our project we have seen that a random forest and gradient boost are the most effective for our project. And for a future work, larger and longitudinal data sets can be used, and also mental health and attendance data can also be included, and explainable AI method also can improve interpolation. So this is from this is our project. Thank you.